So for this question, the first thing that we notice is that there is not an integral rule, because remember, when you differentiate, you go from one trig function to two trig functions. So when I integrate, I go backwards and I go from two trig functions to one trig function. So here I just have one trig function. That is not going to be an integral rule. It's not going to become secant squared. So remember, the process is you ask yourself, do I have any rules? And I don't. Then you ask yourself, can I simplify? And tangent is as simple as it's ever going to get. But we don't know how to integrate tangent. So we say to ourselves, well, maybe I can convert tangent in terms of sine and cosine. So let's see what happens when we do that. So if I write tangent as sine x over cosine x, then I have converted the problem. And now I say, okay, well, how am I going to integrate that? Well, I don't have a rule for it. There isn't any simplification. So that leaves me, for this particular integral, with u substitution. Now, remember, if there is ever any question in your mind about what substitution to make, if there's ever a toss-up, you are going to choose the denominator. So I'm going to start by choosing u as cosine x, and then my du. Okay, now I want to be very clear about something. When you have sine and cosine, you have to be super on your toes about what is negative and what's positive. So that's where we use this is dc negative. So when I differentiate cosine, that is going to give us a negative sine x, and then dx. All right, so plug in this stuff in. So this cosine x is going to become u, and hopefully we're getting really good at this and we can just kind of go to this du. So du is negative sine x. So we have the sine x, we have the dx, we need a negative. Now if I multiply in by a negative, I got to multiply on the outside by a negative. So then all of this will become my du. So when I rewrite this integral, I will have negative integral. We'll talk about the bounds in a moment here. The numerator is becoming du, and the denominator, all this cosine x stuff, becomes u. Now, let's talk about the bounds. These bounds represent the variable of integration as x is equal to pi over 4, x is equal to 0. So if you now have the integral all in terms of u, you need to switch the bounds to u1 and u2. So the whole entire integral is in terms of u. Now, once the integral is in terms of u, we are ready to integrate. And again, sometimes people start adding or moving up the u and then add 1 to the exponent and see that they have a 0 in the denominator. When that happens, you say to yourself, that's a natural log. So this particular question, this du over u, hopefully you're getting good at this and can recognize that that's natural log. But again, anytime you have a 0 in the denominator, that is your natural log. All right, so we have natural log absolute value of u to make sure that this argument is positive. Again, keep that negative constant. And then we have bounds, so there's no plus c involved. We'll have our bounds of u1 to u2. All right. So we need to, after we integrate, we need to substitute back. So we have our u integral, we integrate, we substitute back. So u was equal to cosine x. So we'll plug that in. And now that we've substituted back in terms of x, this u1 and u2 will switch back over to the original bound of 0 to pi over 4. Okay. All right, so we're going to start by plugging in pi over 4, the top function. So we'll have, and again, this is our fundamental theorem in action. We'll take the upper bound minus bracket, the lower bound plugged in. So we have minus natural log, absolute value, cosine pi over 4, minus from the fundamental theorem, and then in brackets here, I'm going to put the lower bound plugged in with 0. So minus natural log cosine of 0. And then my goal is just to try to simplify all of these natural logs. All right, so here we go. Cosine of pi over 4 is square root of 2 over 2. That is a positive number, so the absolute values are no longer necessary. So we'll just have natural log square root of 2 over 2, and then the minus. Here we have minus, and then inside of the bracket we have minus natural log. Cosine of 0, again, looking at your little unit circle, cosine of 0 is 1. So we'll have natural log of 1. Now, natural log of 1 is one of those numbers that I really want you to know. So natural log of 1 goes to 0. So all of this is wiped out as just a plus 0. So that leaves us with the goal of simplifying minus natural log square root of 2 over 2. Now, do keep in mind here that you can use log properties, because when you have this square root, that can be written as 2 to the 1/2 power and then over 2. So if I bring this 1/2 power out in front, then what I will have is I will have minus 1/2 natural log of 2 minus, and then this denominator. So again, we want to think about the numerator minus the denominator. So it will be minus natural log of, or 1/2 natural log of 2 minus, and then we have our natural log of 2 as the denominator. So if we combine that, now we do need to be a little careful here, so let me be very clear. So let's put, I don't want this to cause any confusion. So let's say, let me go back, I apologize, just really quickly here. So you're dealing with this, okay? So you have this minus sign, you have this natural log square root of 2, and you would probably start by dealing with the denominator. So you'd have natural log square root of 2 minus natural log of 2, okay? So just to be very clear, this is our numerator minus our denominator. Now, you could then say that this square root would become 2 to the 1/2 power inside this bracket minus natural log of 2, and that minus comes down. So then, by your log property of bringing down your exponent, you could bring this exponent down in front. So it would become 1/2 natural log of 2 minus natural log of 2. Then you could say, okay, I have a natural log of 2 here, natural log of 2 here, so those are like terms, so I can combine them. Now, if I take their coefficients of 1/2 minus 1, that is going to give us negative 1/2 natural log of 2 inside of that bracket. But we still have a negative from all of that negative coming down in front. So now we have a negative times a negative, so that gives us a positive 1/2 natural log of 2. And then multiplying straight across, we can say it's natural log of 2 over 2. And that would be one interpretation or one way of writing the final answer. So I apologize for that little skipping steps there. I apologize. I think it's better if we just do it as 4 separate steps here. You get natural log of 2 over 2. I do want to mention, if you want to just leave your answer like this, that's totally fine with me as well.